I just wanted to talk about our module 13.2 volume of cones notes today. So what we're going to do is we're just going to go through the notes together and take a look at vocab and a couple examples. So to start off with our vocabulary, a blank is a three-dimensional figure or a 3D figure that has one vertex and one circular base. So that would be a cone. So we'll go ahead and put that there, a cone. And a cone looks like this shape right here. So it has a circular base and then it ends up coming up and then meeting at a peak at the top. That is what we call a vertex. So some examples of cones might be, let's say, ice cream cone or traffic cone or a party hat. Those are some examples of objects in the real world that look like cones. Now to find the volume of a cone, what we're going to do, and I'm going to skip over this bullet point and just give you the actual formula for it. So the volume of a cone, what we are going to do is we are going to multiply by 1/3 or divide by 3, and then it is pi r squared times h. So that is our volume of a cone formula, 1/3 pi r squared times h, where r is the radius of the base, so you can see that right here, and h is the height of the cone, so however tall that cone is. Those are the two measurements that we are going to need to know. Again, just as a reminder, when we're looking at the radius of a circle, that is just half of the length of the circle, right? So radius is only from the very center to the edge. It's not the entire thing. It's only half the length of that circle. So that's one important thing to remember. We are looking at the radius, not the diameter. So let's take a look at an example and try to figure out what the volume of this cone is right here. And as we can see, sometimes these cones are going to be in different, they're going to be laying different ways, right? So this one right here is laying on its side. This one is also laying on its side. The example up top was standing upright. So it doesn't really matter which way, what direction they're lying. We always want to remember the radius is half of the circle. The height is from the circle to the tip top or the vertex. So in this example right here, our radius is 5. So that's our r, right? And our height is 9. So that is our h. And what we want to do is we want to just look at this formula again. V is equal to 1/3 pi r squared times h, and just plug in what we know. So for here, what we're going to use for pi is 3.14, right? So we're going to have volume is equal to 1/3 times 3.14 times r squared. Our r here is 5 squared times h, which is 9. So all we are doing here is we are just plugging in what we know, right? 1/3 stays 1/3. Pi we turn into 3.14. R squared is 5 squared. H is our height, which is 9. So we are just plugging in what we know. So what we want to do from here is we want to simplify where we can. So we have volume is equal to 1/3 times 3.14. 5 squared, remember that just means 5 times itself. So 5 times 5 is 25, and we still have that 9. Now what we are going to do here, what we want to do is we want to multiply all of these things together. I'm going to take one extra step. I'm going to leave this 1/3 by itself first, and I am going to multiply everything that is a regular whole, or not whole number, but a regular number here, not a fraction. So 3.14 times 25 times 9, we can just plug that into our calculators. Actually, let me pull up the calculator here. Do that together. So we are looking at 3.14 times 25 times 9 is equal to 706.5. So we have 1/3 in the front, 706 what was that, 9? 5 on the inside. Now we have one last step. when we are multiplying by a fraction, that is the same thing. 1/3 multiplying by a fraction is the same thing as dividing by the denominator, so dividing by 3. So what we can do is we can take this 706.5, and instead of multiplying by 1/3, what we can do is we can divide by the denominator, which is 3, the number on the bottom. So 706.5 divided by 3 is 235.5. So that is 235.5. And here we are measuring in feet. So it's going to be feet cubed. Again, remember, we have to label our units as cubic units. So we have to have that 3 exponent right there because this is a 3D object. We are talking about space. We're not talking about length anymore. We're talking about how much space is inside of this cone. All right. Now I'm going to go ahead. I'm going to skip that next example on that page, and we are going to move on to the last example on page 12. So let's go ahead. Let's scroll over to page 12. And I want to talk about this one together. So we have a large traffic cone, stands 28 inches in height. So what we can do is we can actually, let's start drawing this. So traffic cones are orange, right? Let's see. Do we have orange here? Yes, we do. So we've got the bottom, which is a circle, right? We're going to want to know that radius. And it's going to look something like that, right? Let's go ahead. Let's draw our height. And actually, let's do it in blue. So what we know here is we have a large traffic cone. Please excuse my drawing. I am not an art teacher. My bad. Miss Martinez would probably be very disappointed in me. So we have a large traffic cone, stands 28 inches in height. So we know that our height is 28, right? So this blue line right here is 28 inches. And has a volume. So we actually know, this time we know the volume. So all the space on the inside of this right here, if we took all that space, our volume is equal to 732.7 inches cubed, right? That's our volume. What we are looking for is the, let's use, what color do we want to use? Let's use like purple. We're looking for the diameter of the base. So now, we want to be very careful. Here we have a radius, right? That's what we normally are looking at. We're looking at the radius, but this time what we want to find is we want to find that whole diameter, right? So we're looking for D. But in the formula, I just want you guys to remember in the formula, our formula uses R, right? So our formula, we are using R. So let's go ahead, let's rewrite our formula down here. So we know volume is equal to 1/3 pi r squared times h. So what we want to do is we just want to plug in everything we know. So we know what V is, right? We know V is 732.7. So anywhere I see a V, I'm going to plug in this 732.7 is equal to, now I'm going to have my 1/3. Pi, we know, is 3.14. Right? Let's see. Let's try to make that look a little bit better. 3.14. And then my R, we do not know yet, right? So we're gonna leave that R squared. We don't know that part right here. They didn't tell us anything about my radius or my diameter. And my height is this 28, right? My height, they said, was 28 inches. So from here, what we're going to do is we're just going to simplify where we can. So let's look at, let's see, I'm going to scroll down a little bit. Let's look at the left side of the equation. We are going to keep that 732.7. We're not going to do anything to that yet. Then on this right side, let's combine all of the numbers that we can. So I'm going to leave this fraction again. I'm going to leave that. Now, we have a 3.14 and we have a 28. Those are the two regular numbers that we have, right? We can multiply those together. Let's combine them. So 3.14 times 28. So 3.14 times 28. Now we get 87.92. So 87.92. And then we still have this r squared. We don't know what that is yet, right? Let's keep going. See what we can combine. So 732.7, that's all I've got on that left side. We're just going to keep it. Is equal to, now I'm going to combine these two numbers, right? 1/3 and 87.92. Again, remember, if I have 87.92 and I'm multiplying it by 1/3, that's the same thing as dividing it by 3. So if I take that and divide it by 3, we're going to get 29.3, about 29.31, right? So 29.31, and then I still have this r squared. That r squared is what we are looking for, right? We want to solve for that r. So what we're going to do is we're going to get rid of the 29.13 by dividing it. 29.31. And whatever I do to one side, I'm going to do it to the other. So 29.31, divide both sides. Now, if I go ahead, let's do that left-hand side, 732.7 divided by 29.31 is equal to about 70. Did I do that right? Hold on, let's redo that. 732.7 divided by 29.31. There we go. I think I plugged it in wrong. Sorry about that, guys. So we get about 24.998. So let's just round that to 25. So we have 25 over here is equal to, that cancels out, right? And all we are left with is r squared. Now, our very last step is we want r by itself, but we have r squared currently. So what we have to do is we got to do the opposite of squaring a number, which, remember, in Pythagorean theorem, we looked at that. Opposite of squaring a number is taking the square root. So square root of 25 is 5, is equal to r. So we have that our radius is 5 inches. So radius is 5 inches. But hold on, we weren't looking for the radius. What were we looking for? We were looking for the diameter of the base. So the diameter is 2 times the radius, right? Radius is only half of it. Diameter is 2 times that. So if the radius is 5, then we know that our diameter is just twice that size. And 2 times 5 is 10 inches. Now, this problem was a little tricky. I will not lie to you. It's a little bit different than what we've seen, right? Most of your problems for your practice problems are just going to be exactly like this right here. All I'm asking you to do is find the volume. So all you have to do is you have to plug in the radius, you got to plug in the height. Only thing to remember is we are using the radius, which is half of the length of the circle, right? Sometimes I might give you diameter. That means we need to divide that diameter by 2. So worry more about this problem, this example right here. Maybe go back, rewatch the video if you're still struggling with that. This problem is just more of a challenge problem. I will not ask you to do anything even nearly as hard as this one, so don't stress about it. If it's confusing you, it'll be okay, I promise. All right, guys, I hope that you have a great day, and I will talk to you